Now that we have had practice simplifying radicals, let's go ahead and flip to the part that says rationalize the denominator. And what I want you to write is that a quotient with a square root, so a quotient with a square root in the denominator is not simplified. So if we end up where we have the square root on the bottom of a fraction, we are not done. This is not simplified. In order to simplify, we must multiply the fraction by a 1 to get a perfect square radicand in the denominator. So I want you to write that to simplify, you need to multiply the fraction by 1, so it's not really going to be a 1, it's going to be a fraction that equals 1, to get a perfect square radicand in the denominator. So what that means, I want you to make a little note here. If I were to say that a fraction was the square root of 7 over the square root of 7, well, remember, anything divided by itself is equal to 1. So that's something that we could potentially have to multiply by in order to rationalize the denominator. So let's take a look at what this looks like. So if we look at example 8 here, we have 7 over the square root of 6. Well, remember, I just said that if there is a radical symbol or a square root in the denominator, this is not simplified. So we need to go ahead and get rid of that. And we are going to multiply this by 1. And that 1 is going to include the square root 6. So if I make a 1 by saying the square root of 6 over the square root of 6, which is equal to 1 because anything divided by itself is 1, I can then go ahead and rewrite this as 7 times the square root of 6 all over. Well, remember, I can go ahead because of the product property and write this as the square root of 6 times 6. And then I can rewrite that as 7 times the square root of 6 all over the square root of 36. Well, here's our perfect square radicand. I can now reduce this to say the 7 times the square root of 6 all over, well, the square root of 36 is 6. And that is actually the simplified answer. It may not look more simple than that, but because we cannot have the square root in the denominator, this is actually simplified. Let's go ahead and try it now for example 9. We have again a square root in the denominator. It's not allowed, it's not simplified. So we have to multiply it by a 1. Well, what's that 1 going to be made of? Hopefully you said that it's going to be the square root of 5a over the square root of 5a. So we basically want to multiply by a fraction that's consisting of the square root that's already in the denominator. So on example 8, I took the denominator, which was square root of 6, and I made a fraction that was square root of 6 over square root of 6. On number 9, the denominator is the square root of 5, and I'm going to make the fraction square root of 5a over the square root of 5a. So let's go ahead and do the math. We have the square root of 3 times 5a all over the square root of 5a times 5a. 3 times 5 is 15, so on top I have the square root of 15a, and on the bottom I have the square root of 25a squared. 5 times 5 is 25, a times a is a squared. Well, I do not know the square root of 15, and even if I were to break it down, there's no numbers that I can break it down to that are a perfect square. And same thing with a, so we're going to have to leave the numerator the way it is. So we have square root of 15a on top. Well, let's look at the denominator now. 25 is a perfect square, and so is a squared. The square root of 25 is 5, and the square root of a squared is a. That is our simplified answer. So now you know how to rationalize the denominator. The only other thing we have left to learn about radicals now is to add and subtract. So if we flip open the last flap, I need you to take a few notes on this top part. And we are going to write that like radicals can be combined by adding or subtracting. Like radicals can be combined by adding or subtracting. So you want to think like terms. So like we said that we cannot add x plus and y together. They're not the same term. We cannot add the square root of 2 to the square root of 10. They're not the same thing. But we can add the square root of 2 to the square root of 2. And we'll see that in a little bit. Next note is that you add or subtract the coefficient and keep the radical the same. So we add or subtract the coefficient and keep the radical the same. So that means that we would add the number on the outside of the radical symbol, but the radical itself, if they are like terms or like radicals, we keep the inside the same. We don't change the inside, we just change the outside. And then last, sometimes you need to simplify the radicals before adding or subtracting. So let's take a look now at example 10 and 11. So number 10 is the square root, or 7 times the square root of 14 plus the square root of 21 minus 4 times the square root of 14. So like we would in an algebraic expression with just x and y's and letters and numbers, we can rewrite it so that like radicals are next to each other, so it's a little easier to see what's going on. I can write this as 7 times the square root of 14 minus 4 times the square root of 14 plus the square root of 21. I wrote the two radicals that are the square root of 14 next to each other because they are like radicals. They both have a 14 on the inside. So like we said, we're going to add or subtract the coefficient, the numbers on the outside, and leave the inside the same. Well, 7 minus 4 is 3, and then I leave the inside the same, so I have 3 times the square root of 14, and then plus the square root of 21. I'm done now because 14 and 21 are not the same. The square root of 14 is not the same as the square root of 21. That's as far as I can go. Let's take a look now at number 11. We have 5 times the square root of 7 plus the square root of 28. Well, right now they do not look like they are like radicals. But we did say that sometimes you may need to simplify the radical before you can add or subtract. So let's go ahead and take a look at square root of 28 and see if we can simplify this at all. I know that I can't do anything with 5 times the square root of 7. 7's a prime number. It's not a perfect square. But the square root of 28 can be broken down into 4 times 7. And 4 just happens to be a perfect square. So I can rewrite then this as the square, or 5 times the square root of 7 plus the square root of 4 is 2, so I'm going to have a 2 on the outside. And the 7 is going to stay inside because I don't know what the square root of 7 is. So now I have like radicals. And I can go ahead and add the coefficients on the outside. 5 plus 2 is 7. And I leave the inside alone. So my final answer is 7 square root 7. And that's it. You've now learned everything you need to know about radicals. We will go ahead and practice some more tomorrow. Have a good night.